Hey, hello everyone. Thanks for joining me today. My name is Baz. Today I'm gonna introduce a very innovative concept called LCM. What is LCM? Well, let's go into deep dive. So LCM stands for Large Concept Model. What is that? It's next level of token processing. It's beyond token level processing. It's gonna revolutionizing the AI with higher level of semantic representations. Before we goes into the LCM, let's understand what is LLM, the large language models. The large language models have revolutionized the field of artificial intelligence, and it's emerged as a go-to tool and to do a lot of work orchestration task, and it's revolutionized entire the digital industry, and it's created a kind of its own um, uh, equilibrium into that. So let's understand how the LLMs is gonna works. So LLMs works into transformer based architecture. Before I'm going in a deeper architecture level, I'm gonna explain to you how it's gonna work. So it has raw data, uh, language modeling, and it's trying on self-supervised and mask token predictions. It means like it works on the tokenization, the kind of like the token level processing with semantic context, and we know the what is a problem with LLMs. So LLMs fail to think how human is gonna think. That's the major challenge with the LLMs. So if you give the context or a situation to the LLMs, it's may not able to understand the what context is talking all about. So to show you that what is a exact problem in LM, I try to ask like how many letters are letters in a strawberry with my copilot, and it says like it has two R letters. We all know it's not, and I tried with Gemini. It's done pretty good, but it has a knowledge base. That's where it's answering to go to the internet, it's searching it, and then it's answering it. But when it comes to Meta, it says like it has three letters in the word strawberry. But how that's happened? One. So let's go. Uh, how it's been convert into the sonar vector, how explicitly it's count the R occurrence and given the output in Meta. So Meta is released the large concept model paper, which has been here. It talks about like how the large concept models have been trying to perform the autoregressive sentence predictions in embedding space, which I'm gonna explain pretty detailed level here. So so how the LLMs works? LLMs is gonna be whenever you give the input and it's considered as a token. That means like if you say the strawberry word, it's considered as straw and berry. It's work on a token level, character level information, but it doesn't have the relationship between the words. And that's where it's do the tokenization and embedding layer. From there, it has a transformer blocks, which is like self attention mechanism, and we have the feed forward network, and it's gonna gives the output result, and that's where like it doesn't have that prediction based the context, and it's rely on the on the pattern of recognition because it's been trained on the huge chunk of the raw data which has not been labeled. Um, so there is a different ways we can solve the problems, but the meta, the way they introduce it with a large concept model, I would like to inform. So how the LCM gonna works here. The large concept model is architecture is into the sonar embedding. So it means like it knows the relationship between the letters and words. It's gonna be work, and it's been semi-supervised the training, and it's been on the nest concept prediction level, and it's co understanding the sentence level, and it's language agnostic, which means like it's gonna be you can train with the LCMs, and which are the language which you want it to be interactive. It's easy go kind of the ones, and its benefit it's language independent. It's improved the semantic understanding, and it's efficient processing. That means like we no need to burn huge compute in terms of like processing into the large language models, and get the same boring context non-context information from the LLMs. So I'm gonna show the visual representation how LCM model is gonna works. It works into the concept of decoder fix and encoder is fix, and input and output, and it has a between it has a large concept model, and it's both encoder and decoder as frozen. It's been like a teacher and a student kind of understanding between that, and that's a great advantage because it knows it's capture the semantic relationships, and it's having 124 dimensional float vectors, and in the transformer layer self attentions and uh, feed forward neural networks is going to work, and it's trained on the labeled and unlabeled data as well. So it knows the concept like what the next thing is going to come. So let's say it's like Tim is wasn't being athletic and he thought it would change him if he joined the sports. That it means like it understand the concept, and then it's gonna provide you the accurate information that he is a sporty athletic guy. So this is a speech encoder, the speech input and text multilingual teacher and the student one. And what is a difference between um, LM and LCM? So LMs are token level text processing. That means like number of the tokens which are given, the 4,000 or 8,000 token. But LCMs are the concept level understanding, that it understands the concept, and it's gonna respond to it. And if you take the input of the LLMs is being words and token, but LCM is complete idea and action to it. And it's language dependent when it comes to LCM, LM, and LCM is language agnostic. And modality, multi LLMs gonna do the ones, but our LCM is outperforming to multimodal test and speech. So So if you go the model characteristics, it's stock the same, but other key features, if you goes at the concept wise, it's seamless across the languages, right? It has a deeper understanding, and it has zero start short generalization as well. LCM has a different variant. It's a base variant is LCM. Base LCM is a standard transformer decoder, which minimal loss, and it has PreNet and PostNet normalization, and it has diffusion-based LCM, which is autoregressive concept. generation, and it has a two tower and one tower models as well, and it has a quantized LCM. It's a vector quantization. Um, so what that means, let me go into the each model wise. So base LMs is gonna minimize the errors between the predicted and actual concept, and the input and output is gonna be normalization. But however, when it comes to diffusion-based LLMs, is one tower and two tower models. One tower is a single transformer tower for generation, and two tower is separate towers for the context encoding and concept generation. So it's completely what I said, like teacher and student ones, which has the concept encoding and context encoding and concept generation. And when it comes to quantized LCM, it depends upon how you control the temperature, top D and K parameter. It's create more uh, control generation of the data, which you can able to do it, and the comparison between the each layer. So each variant, the base LCM is medium in term of the complexity, and generation style is non auto regressive, and advantages is very simple and efficient, and diffusion based LCM is high in complexity, but its generative style is auto regressive and capture the sequential relationships. Quantized LCM, it's in complexity is low, and it's fast in memory efficient. So it's depend upon which variant which we wanted to choose it in LCM. We can go ahead and choose that. And performance wise, when you perform, do the comparison between LLM and LCM. So if I given the task, text summarization is good, LCM is excellent because it's know the each context of that and relationship, so it's perform much better in terms of the benchmarking. The wise the language translation, it's been excellent, and the complex reasoning, it's excellent. And training requirement, ALM required large corpus of text data. It's require large concept undated corpus data. That means like it works on both unlabeled and labeled the data, and training complexity is higher in when it comes to the LCM. A real world application, it's suitable for chatbot, content generation, decision making, autonomous vehicles. Is LCM is far better, and understand uh, lack of common sense. LCM sometimes it doesn't understand what context it talks about, but it's been addressed in LCM pretty well. And domain knowledge, it doesn't have the expertise domain knowledge, but LCM is partially addressed that one. And adversarial attacks, LLMs are more vulnerable, and LCM are lesser vulnerable uh, because of the architecture wise, and how abstract reasoning is works into the LCM. LCM is focused more into the reasoning processing rather than being into the language or modality. It's learned across all the language and format simultaneously. So you don't need to train into the different languages which we used to train with the transformer models, where we have to train each different languages. But in LCM, it's been pretty straightforward, and it use explicitly, it's improve the readability and long format contents as well, and it's easy to edit them. and zero shot generalization. It's generalize any language and modality has been trained without needing any additional data. So that's great advantage of that. In summary, LCMs are better in terms of like if you want to have a deeper reasoning, cross language capability, and semantic understanding. So LCMs have the kind of like far advantage when it comes to LLMs one, and it has a broader application and include the complex decision making and creative content generation, which can be done in LM. So before I wrapping up, I would like to you guys to go through the LCM paper which is being published, which has kind of like how the sonar embedding space is gonna be works. It has a deeper level of like explanation. It has been compare which of the GPT, Gemini, Claude, and Bloom, and how it's been the model input and output when you have considered that. So how it's been work and how the data preparation in LCM works. Um, it's has a spacey one which understand that relationship. As I said, like we have a basal lumps, which is like a PreNet and PostNet, and we have um, 1 tower and 2 tower diffusion LMs as well. So this paper is going to give you the clear understanding of how this LM is LCM works, each model level. Oh, it's gonna give the complex in terms of the nature of it. And here is this important GitHub link where it's gonna shows you how the new multilingual and multimodal fixed sentence embedding space, that's nothing but a sonar, the one, so how it's gonna work into the test encoder and decoder. And this is the sonar architecture which is like student teacher and student a relationship which having it, and it's gonna show so like the speech results in different speeches. So you don't need to train your model into the different language. So it works into the multi-language itself. That's advantages of LCM. And um, we have the different link as well. I'm gonna post you in my YouTube channel, so you can start playing with the LCM. You can go and download it. So you can go here and you download this paper, and you can go and understand each of the um, GitHub link. The links are already been here in this paper itself. So if you go here, you can able to get into the same way. I'm gonna share that as well. This is a language model in a sentence representation. How LCM is understanding the each sentence in high level kind of a semantic representation. How the approach is gonna be looks like both concept decoder and concept encoder is being fixed. How you're gonna install um, it, the repository. It has a detailed one, and you can start pre-trying the models depending upon the base LCM, 1 tower and 2 tower diffusion LCMs, and fine-tuning the models, however, which is way suitable for your requirement wise. And you have those data annotated, the ones, and how you can start training both annotated and unannotated data as well. So that's it. We come to the end. Thanks for watching, and I hope you like this the new revolutionized concept of LCM that gonna change the how you're gonna think into our artificial intelligence in coming days. Yeah, thanks for watching. Thank you.